Hi. In this video, we are going to talk a little bit more about the importance of symbolism and how easy it is to embed unconsciously ethically problematic things into any data visualization. The example I'm showing here is a calendar that shows the events that are happening on a seasonal basis. And you can see that this calendar is nonlinear. This calendar is very, very easy to read if you are raised in the culture that uses this calendar. But this calendar is almost impossible to read if you are raised outside this culture. The same thing is true for this data visualization. This is a map that is meaningful to people who are very familiar with the culture of this type of map and almost unreadable to people who are not raised in this culture. And how we solve this problem, how we make symbols meaningful to people who are not raised or educated within the culture that gave rise to the symbol, is something called a legend. Almost every map that you see has a legend, and that legend will tell you how to read the map. And the same needs to be true with any of the data visuals that you put into your data stories. It's essential that your legend does more than just tell the basics of, this is up, this is down, but actually helps people who were raised or educated in a different culture how to read and understand and make sense of your data visualization. And the reason for that is it's extremely easy to accidentally embed all kinds of worldviews and beliefs into symbols. And we're going to look at one final visual example here of an image that is used widely across textbooks. If you Google equity versus equality, you will find it over and over and over again on the internet. And we're going to show you how a seemingly innocent data visualization actually is very problematic in terms of the unconscious symbols that are embedded into this product. So this is used to illustrate the difference between equity and equality. And equity and equality are two different ways of treating people. So in this example, we start off with three people of three different heights that are all trying to look over a fence. And the person on the far right, you can see, is too short to see over the fence. And the person on the far left is tall and can see over the fence easily. If we treat these people equally, we give each person a box. The problem with treating people equally in this way is that the short person on the right still cannot see over the fence, and the tall person on the left, who could always see over the fence, can still see over the fence. So this is an example of why supporting people in the exact same way, regardless of their needs, might be equal, but it doesn't necessarily have the result we were hoping for. This, in the textbook illustration, is the result that we are looking for, and this is called equity. And so this is how we achieve equity. We give each person the support relative to how they need the support, in what way they need to be supported. So the person on the left, who can already see over the fence, doesn't get any boxes. And the person on the right, who is the shortest person, gets 2 boxes. So then that person can see over the fence. This is a very well-intentioned data visual, but it's extremely problematic. The problems with this are multitude, but the fundamental 2 problems are that by making the people 3 different sizes to start with, we have embedded the idea that the reason that these people need aid or need support is because they are different sizes. It's intrinsic to the people. They are born this way. And that is not generally the worldview that is meant to be portrayed by the people using this data viz. So we start out our new and improved visual with the people all being the same height. so that we're not implying that the different need for aid is based on the different intrinsic, inborn aspects of the people. The second problem with this visual is that the barrier, which is represented by the fence, is shown to be at the same height for everyone. So in the original visual, the barrier is at the same height for everyone, and people have different relationships to the universal barrier based on an intrinsic value, the height in which they're born. However, if you've lived as a human on Earth, you are aware that the barrier is not one universal barrier, that in fact, people are all born the same height, but the barriers are quite different for different people. And even if the barrier is the same, as it is on the far left and the far right in our new illustration, where you start out, the ground that you're standing on, the community and the supports that you find yourself born into or born with are not at all the same. So the variations in the ability to see over the fence or overcome the barrier has nothing to do with the height of the person. It has to do with the structural height of the barrier and the ground that that person finds themselves standing on. So this is a much more accurate representation using symbols of the world as it exists. The data viz has been created much more intentionally from an equity lens in this point. And this is our final outcome, not people standing on boxes so that they can see over the fence, but actually fixing the structural problems. So you can see, this is a very simplified example of how deeply embedded even our well-intentioned data viz is with unconscious worldviews. And it's essential that you take some time to go through every single data viz that you're creating as a data journalist and ask yourself, whose worldview is embedded in the symbols that I'm using? Whose worldview is embedded in the colors that I'm using? Whose worldview is embedded in the perspective that I'm using for this data viz? And a worldview will always be embedded. I'm not saying try and make it objective, because we're back now to where we started. It's not possible to create an objective data viz, but it is possible to create an intentional and transparent data viz.